Welcome. We here. I think we're gonna do the level now. We're going to discuss the sigma and sigma summation. For the integral, I think we can stop for a while now, and we focus on the sigma. And I believe the next chapter you will know what we're going through, which is the Riemann sum. But now we first let's talk about sigma. So what is sigma then? So let's just write out what the sigma is. And more important thing is we have to understand the symbol, the label. So this is the label for sigma. Very easy to remember. It's like a sideway M. And of course, the below here is what we start. Usually we label them as I. I label it. Again, it can be anything. It can be n, so it can be like n, it can be anything. So it's just whatever you want. So I call it I for symbol. The reason why, because we call them index. I is equal to something, and at the top here is the last number of the index. What are index? What am I talking about? So yeah, so let's just stop thinking that for a while. Let's just understand more about sigma. And now I'll introduce the notational index following it. And so why do I need sigma? Okay, so let's think about, let's add 1 plus 2 plus 3 plus 4. And I'm telling you to keep writing this and keep writing this until, let's just think a number like 10,000. Let's assuming this. Um, and of course, like if you want to write something that's accumulate all of the things together, you have to write everything out. So for example, if I add 10 here, right? And so you have to add like, so go like 11 at 12, 13, 14, like 15, 16, 17, 18, 19, 20, and then continue 21, and then you go on, right, until you reach to 10,000. Is pretty long. And of course, if you keep moving on, I think you need, like, for this like tablets, on the pages and that's on this tablet, I think you have needed even more than 3 pages, and it keep going, right? And if of course the number gets bigger, you have to write a lot more. Um, because, well, you don't have any other way. If you have, yeah, you don't have any other way, alternative way to writing this whole sequence of sum, and that's the reason why we need sigma. Okay, and so how can I represent this in sigma form? So let's write out the sigma first, okay? And as I saying, we have an index. All right, let's just make it beautiful, so like this. So we need an index, okay? So I like usually label I, you can label it anything, okay? Like A, B, C, D, and even just whatever you want. So I labels I as an index. So what's my index? It's depending on where I start counting my number. So if I start counting, this one is 1, my index start at 1, continue 2, 3, 4. It's like a numbering system, or like indexing your numbers, your sequence. So if I keep going 5, right, 6, and right, 7, right, here's 8, 9, 10. And of course, if I keep going, the last one here would be 1,000, 10,000. Okay. And so since my index start with 1, and so I may say I is equal to 1, and my last index is 10,000. Okay. What am I adding? Now, of course, you may see that I'm adding all the indexes together, right? So it's like 1 plus 2 plus 3 plus 4, and my index follow them. So 1, 2, 3, 4 is I'm adding everything together. So what I'm doing is putting index I. Okay. And so of course you may see like some different labeling. So this is like how you're gonna write the sigma sum. Of course, there's an alternative way for you to write it. It all depends on your index, right? So for example, let's just bring on another example. Let's just say, well, I don't, so let's just write a sigma here, right? And let's just say, I don't like my index start with 1. I like my index start with 0. Okay. So index start with 0. So right below the sigma, say I is equal to 0. And I will have to count, right? To find what my last index is. So I put my first index is 0 here, right? And continue 1. This one is 2. This one 3. This one 4, 5, 6, 7, 8, 9. Now you realize the pattern, right? And of course, the last one would be 9,999. Okay, so that is my last index. And so my last index is 9,999. What am I adding? Now, of course, I'm adding all the indexes, but trying to remember that even though my index start with 0, this is my index, but my real number on the sequence that I want to add is 1 when my index is 0. So what I'm going to do is have to add 1 here, right? So that everything is balancing out. So when my index start with 0, 0 plus 1 is 1. So at my index 0, my first number is 1. As my index is 1, right? My index is 1 right here. And my numbers is 2, right? 1 plus 1 is 2. And I move on, so on and so forth, right? Or again, so let's start with something like less, familiar index. Again, as I'm saying, you can label your index and start any way you want. So if I start my index, let's just say at 4. Okay, so my index start at 4. I'm going to write in this sigma. And so my index start at 4. So this one here is 4. It continues. This one is 5, right? This one 6, 7, 8, 9, right? 10, 11, 12, 13, right? And so on and so forth. And this one over here, now remember my index started at 4, the last one. So again, so there's a difference here, right? So you can see there's a difference right in here. You can make this as a difference. So and how is it different? Well, we're gonna write out the equation. So again, if I start my index as 4, right? Index as 4, and my last index would be 10,003. Of course, when I start my index at 4, I have to subtract 3. So that when I start my index, right, I subtract it out. So when I start my index at 4, so when 4, right, when the index is 4, subtract 3, then I get the numbers 1, right, continue, and my index is 5, and I subtract out 3. I start with number 2, right, and add 3 and so on and so forth. And so this is how we are doing with the sigma and sigma sum. That's basically the idea of it. So you notice that there is a property of a sigma. So you noticed already, congratulations, good job for noticing this. So again, so let us say in the general rule, so this will be a property. Now, of course, I'm not going to too much of details of property and stuff. Unfortunately, you may need to read it more, so you can research more. I won't take out my time to talk too much about property of a sigma, because I don't feel there's an important right there. So everything about properties that we talk about in the Riemann sum, but I don't feel this is much of that important at this point of making this video. So that's the reason why I'm not going to talk a lot in the property yet. Okay, and so my apology. So yeah, so when my index start with 1, right? Let's just say, sorry, when my index start with A and end at B of this, Then my first property is that, well, property one is that if I, change, so let's just look at this. So if I minus all the index with a certain number, let's just say k, let's not say one, let's just say k, then my index here, my formula has to add k back. So if I index subtracting k, my formula had to add them back. Same thing happens. So if I, well, again, if I, add the k back to it, or a plus k, then the formula will subtract k out. Okay, and so this is a kind of first most important thing that I want to bring out. And that kind of thing right now is the kind of like the most important thing for like the index for us to notice. There'll be some trick around there, of course, in the future. But for now, let's understand it. So if you have any question, put in the comment, let me know. So yeah, so that's it with the index. Not like that's all with the with the sigma of 1 plus 2 plus 3 plus 4. Now let's look at the terms, the number of terms inside the sigma. So let's just say 1 plus 1 plus 1 plus 1 plus 1 plus 1, right, plus blah, 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 plus nth time. Right, so so my question now is there another way for writing this kind of sum? All right, so let's just say the last one is 1. Let's just not like put an n there. It's look weird. My bad. It looked completely off what I was trying to say, but the last one is 1. Okay, and so how can I write in this? Okay, so is there a way to simplify this this form? Well, this is two ways. There are two ways. The first way is, well, oops, shouldn't bring out too many colors. So the first way is that, well, we're gonna count the number one that we have, right? So let's say this one's 1, right, 2, right, 3. We're gonna count them 4, 5, 6, 7, and then 8, 9, 10, 11, 12, until I last number n, right? We've got a number n there. So I'm gonna stop and say, well, they are n times 1, right? So this is a multiplication rule, right? The simplest form that we learn in high school, primary school, and things like that. And things like that. We kind of learned them earlier. And so this is the first way to simplifying this. Now we learn about sigma. Can I do something with this with sigma? The answer is yes, right? And so what I'm going to do is, well, look how many ones I have. And of course, the most important thing again is index. Where am I starting? Well, my index start with 1 in this case. I is equal to 1, not 0, 1, right? And n, my index at n, okay, so that means I have what? 1, because I'm adding all the ones together. So I start with 1, right? 1, 2, 3, 4, they all 1. So I'm adding all the ones together. Okay. And so now here comes a problem that most of us can find hard to grasp. But let's look at this one. Okay, let's look at this one. I'm going to bring an example for this. I'm going to rewrite this everything again, but I'm going to write it so that we have kind of limit, one limit, a limited one, not like n1, but like there'll be a number 1. So let's imagine I'm adding all the ones like 1, 2, 3, 4, and this is the last one, not n, but imagine it's a 10. Okay, and so the problem now is if I'm saying well, if I'm saying I'm starting with index at I is equal to 0. And of course, there are like a 10, 1, the last one following the property there, 9 times 1. If my index start with 0, sorry, my above index shouldn't make sense at all, right? If my index start with 0, okay, so 0, right? 1, 2, 3, right? And my question now is just a challenge. My question is, how can I make this one, not looking at this? Okay, now I'm going to erase everything. Not looking at the other one, but looking at this sigma sum, trying to find a multiplication, rewriting this one in the form of multiplication, right? Here's the problem, right? Previously, if I look at all the number one adding together, then I can say, well, it's right 10 times 1. But if I'm adding this, if I'm looking at this one, how can I write it in terms of multiplication? The answer is following this formula. So if I got B, sorry, index start with A and ends at B, and let's just say I'm adding all the numbers C together, then they are C times B minus 1 plus 1 terms inside this inside of this sigma sum. Okay, so if I'm following this equation, let's just find out if it equal to, if this one equal to this. Okay, so what I'm going to do is again write out this 1 times 9 minus 0 plus 1, that's equal to 1 plus 1 times 10. Okay, so it match. So this formula works. All right, so remember that any case in terms of in terms of the number of terms inside the sigma sum, this is the way we're going to add them up. So I'm going to bring up another example. For example, like if I'm adding all the 4 together, but my index start with number 5 and ends at number 9, let's just say, how many 4s am I adding together? And so the answer is 4, right? 4 times 5 minus 1 plus 1, right? And so for 4, 9 minus 5 is 4, 4 plus 1 is 5. So the 5 number 4s make up adding together to make up this sigma sum. So let's verify this, whether this one correct or not, okay? And so I'm gonna write out, 4 plus 4 plus 4 plus 4 plus 4, right? Let's have 5, 4. My index start at 5, right? So let's write out 6, 7, 8, and 9 is completely matched with this sigma sum. Okay, and so the most important thing is we have to understand this this term